I am S. MOHANAPRIYA, Assistant Professor, Department of Mathematics from KSR College of Arts and Science for Women, Tiruchengood. The topic is Real Analysis 2. Now we discussed about set of measure 0. Let x has a measure 0 if and only if epsilon greater than 0 for every set of open interval a up to k. 1 less than or equal to k to infinity such that x containing I, k and modulus of I, k. Every set of outer measures 0 is measurable. Next we discussed about Riemann integral. Let I be any bounded interval of real numbers and let f be a bounded function on I and the upper and lower integrals are equal, then we say that f is an Riemann integral or integrable. Existence of Riemann integral. The Riemann integral of a function exists if the limit of its Riemann function sums exists as the partition becomes finite. This means that the Riemann integral sum can be made as a closure as deserved to the Riemann integral by making the partition fine enough. Next we discuss about that Rolle's theorem. Assume that f has a derivative if finite or infinite at each point of an open interval a comma b, and assume that f is continuous at both endpoint a and b. If f of a equal to f of b, there is at least one interior point c at which f dash of c equal to 0. Then fundamental theorem of calculus. If f is a continuous on the closed bounded interval a comma b and if f of x equal to integral a to x f of t into dt, a less than or equal to x less than or equal to b, then f dash of x equal to f of x, for then a less than or equal to x less than or equal to b. Now we discussed about improper integral. An improper integral is a definite integral that covered an unbounded area or violent that usual assumption for a definite integral. An improper integral is a definite integral that has either or both limit infinite or an integrated that approaches infinitely at one or more point in the range of assumption. Next we discuss convergence sequence. A convergence sequence is a sequence of number that approaches a specific value as the number in the sequence get larger and larger. A sequence that does not converge is called divergent sequence. Next, uniform converges. A sequence of a function is uniformly convergent if the distance between the function and their limit approaches 0 for all the value of x in the given integral. If uniform convergence can also be defined for the series of functions. Next, pointwise convergence. A sequence of a function f1, f2 up to xn, then up to etc. e contain or converges pointwise on e to a function. Next, relationship between pointwise and uniform convergence. Every uniformly convergent sequence is a pointwise convergent, but the convergence is not true. Non-pointwise convergence implies on uniform convergence. Thank you.